So let's talk about the western boundary currents. We start with the Gulf Stream. So if you cut across the Gulf Stream here at 55 degrees west, look at a map where that is, okay? You can identify the Gulf Stream from the structures of the temperature and salinity fields in the ocean. Okay, this is called baroclinic compensation. The Gulf Stream itself indeed is driven by a gradient coming from the sloping sea surface. The sea surface changes by about 50 centimeters across the Gulf Stream, which is shown here in the top left, by the way. This gray area is the shape of the sea surface, and you can see a rapid change of 50 centimeters over a distance, over something like 30 kilometers or so. In the ocean interior, you can see the mirror effect that this sea level has on the shape of the thermocline. And you can see how deep it actually reaches. This current reaches down to or deeper than 1,000 meters. It's one of the deepest reaching boundary currents. Okay, and you can also estimate the speed, and in this area the Gulf Stream has a speed of 50 centimeters per second, exceeding 50, half a meter per second. This is the geostrophic speed that you can derive, and you can also work out that there are countercurrents. There's a countercurrent. Okay, you can also look into the generation region of the Gulf Stream. Go a little bit closer into the Straits of Florida, okay? And then Cape Hatteras, where it separates from the coast, and you can get impressive details on the currents and how deep it reaches the Gulf Stream. Again, the Straits of Florida, you can see it reaches almost 2 meters per second is the speed near the surface, and it's even at 700 meters, it still has 10 centimeters per centimeter flow speed. This one is, you can see in the top left image, it's a vertical transect showing you the speed of currents. Okay, and the same at Cape Hatteras. Okay, you can see that you have a speed of still 1.5 meters at the surface, and the current itself reaches down to depths of 2,000 meters. One of the most the energetic western boundary system. And the reason for that is, as I showed you before, it actually starts with a very strong current crossing the equator and feeding the Gulf Stream. In terms of volume transport, how much volume it produces, a little estimates here. It actually has a volume transport which increases along with the current. It increases. Okay, it almost doubles along its way. And what the current does, it actually entrains. It creates eddies. And it actually entrains more volume as it goes along. Volume increase. Okay, so this is the Gulf Stream.